So in this lesson for the midterm, we're going to discuss deflection of beams. Okay, so what is deflection, or why do we have to compute deflections? So previously nag-discuss ta about ang isa sa mga measure of strength sa structure is determining if it is determinate, indeterminate, or unstable. So once nga yung structure is stable, so na siya duha ka types na pod nga sayahang pagka-rigid. So it is either determinate or indeterminate. Okay, so what if the beam is already determinate or the beam is already indeterminate, which is makonsider na to nga ang beam is already stable? Does that mean that the beam is already safe? So muna siyang pangutana, no? So we have this term deflection. Okay, so deflection of beams. So deflection is the degree to which structure or structural element is displaced under a load. So ang degree kuno sa displacement. So that displacement may refer to an angle or a distance. So displacement kuno. Okay. So let us say you have a beam. Okay. A simply supported beam with concentrated load at the center. Okay. So pag-apply sa load, ang imuhang unsa may like for example ni nga beam, unsa may effect sa load, unsa may exaggerated nga effect, no, nga ma-illustrate na to once nga load is applied. So basically, if ang load is applied downward, ang imuhang beam will tend to go downward, di ba? The beam will bend, na ay bending, so panang nga bending as kuan structural or civil engineers ato na siyang computon na to ang degree sa iyang pag-bend, sa iyang pag-deflect or pag-displace niya from its former niya nga position. Okay, so the beam kanila siya is an exaggerated lang na illustration, but actually ang deflection yun, kung safe lang yung kuan ang mga structure, dili gid nga nakatako, no, ang displacement. So the displacement could be an angle. So kung magbutang kag tangent dire, so ang tangent mag-meet lang sila sa ka-point. Let's say this is point A, this is point B. So this angle could refer to be the displacement or the deflection, but also a distance can be described with the deflection. So I think lambda man siguro ni siya nga. So that is the symbol for deflection. So either way, mo na sila ang describe sa deflection. But sa ato mostly deflection deflection refers to the distance gi-displace. Okay, so mo na ang deflection. Sa pag-check na to sa structure, na lang tayong minimum requirement for deflection. Say for example, sa beam mostly L over 360, so 360, if you divide your beam length into 360 from support to support, that is the minimum lang downward na displacement niya or upward pa depende sa load. Kamo na siya minimum, I mean the maximum. So dapat dili mo lapas sa L over, kung pilay length ka ni L over 360. Okay, so let us review the ways in solving, I mean in drawing the moment diagram, because the moment diagram plays an important role, no, in solving deflections. Sa atong conventional nga way sa pag-compute, mag-una ta sa load. This is the load diagram. Then we have the shear, and then the moment. So kani upward sa reaction, this is downward for the load P. Then walay load straight, then the reaction, so mo zero siya. Okay, then kung kani straight line ng imuhang ang diagram above sa lower, so for example the shear is 0 degree, automatically the next diagram would be a first degree. Magsunod sila, di ba? Ngana na siya. So ang imuhang moment that is increasing, that is first degree, then minus kani, so that is downward, still first degree. If napog kay uniformly distributed load, okay, say this is W, this is L, so kani this is 0 degree pag straight, no, automatically ang imuha pong shear diagram will be a first degree. So this first degree. Then ang imong moment would be second degree. Pag once nga second, basta 0 degree rectangular, kung first degree triangular, then second degree parabolic. So kung asa nag-up ang zero shear, dito po ang maximum moment. Kung asa maximum shear, na po dito ang zero moment. Pero dili gina always ma-apply. So simply supported lang na siya mostly. Okay, so recall lang nato. Okay, so let us consider a beam. Move na tanong. Ato lang i-recall that ang conventional way is wagi sa tag shear, then the moment diagram, or actually kani M over EI manggit siya, at ginatanggal lang ang EI kay para shortcut lang bali moment diagram. But actually na connected yun si EI. So let us review what is EI. Na-neglect lang ni kay depende maguni sa dimension na sa imong beam. Dili na siya ingon nga sa imong load. Okay. So EI, that is the flexural rigidity. So flexural rigidity or bending stiffness. So unsa na siya? Flexural rigidity or bending stiffness is the stiffness of material when subjected to bending. Klaro na gid no. Ang stiffness kuno sa material when subjected to bending. So ang kalig-on sa or ang resistance sa usa ka material once nga ginabend mo siya. So if naay bending, naay deflection. If naay deflection, therefore naay bending. So connected lagi na sila. Okay? So let us consider a beam subjected to a load. Okay. Kabalon sa porma sa load. Tapos mga moments, applied moments, napay concentrated load. So kani nga itong gidraw kagaina mo ni siyang gitawag na to og elastic curve. Okay. So once nga nakay beam, nakay load, nakay reactions, ang elastic curve ang imaginary or exaggerated curve na ma-form due to the application of the loads. Okay, so this is the elastic curve. Okay. So kung diretso na ta sa moment diagram, yun na ta mo agi o say for example, ma-open niya itong moment that this is the M per EI diagram. Okay, kani dire mo nang ang sa strength of materials mo agi patag shear. Okay, sa conventional way you have to compute the area, di ba, of the shear alisir ka mo abot sa moment. Pero naatay pa maagi sa theory to compute directly the moment nga di na ta moagi og shear, dili na ta necessary moagi pa og shear, naatay way ano. Okay, so kung makita ninyo magbutang ka o tangent diri, so na kay theta. Okay, let us say theta 1. Kung move na po ka diri nga tangent, no, move na po ka, na po ka example, ano to, this is theta 2. Move na po ka diri, theta 3. Okay? So every movement nimo at a certain distance mo change pod ang theta or ang slope or ang angle, no? So say for example ni move ka taman diha so that distance x varies and your slope also varies with respect to x. Okay? So kung mo kani mo itong gitawag og tangent. So kani mo ni siya ang tangent. Tangent mo na itong ginagamit para makita nato gyud ang ma-prioritize na to tanaw ang angle or the theta. Okay, so theta varies as x changes, no? So there's a derivative. Change of theta varies as x changes. That is proportional to the m over ei diagram. Okay, so let us say this is point A and this is point B. So kung imo nang i-integrate from A to B, ma-integrate po din mo. Pero kung in terms of slope lang nimo, say for example, d theta kung ma-move ng x dx in terms of slope lang from A to B. So ma-integrate po nimo siya from A to B. So theta from B to A is equal to the integral of A B from A to B m over ei dx. So theta is the slope of the elastic curve between A and B. Okay, so kung nakay point 3 at B, kaning in between mo ni si A o po ni si B, kaning between sa ilaha duha ka tangents mo na si theta BA or theta AB. Okay, so ito lang gay pa ng concept, no? Anyway, move na ta. So dagag methods sa pag-compute of deflection. Dagag methods, dili lang isa, dili lang duha. There are plenty of ways to compute deflection. So mag-start ta with the most basic, the area moment method. So, area moment method, kani siya nga way of computing deflection is based sa theorem ni Charles E. Green. So siya kuno ang nagbuhat ani nga pamaagi. So kamo na lay mag-research kinsa si Charles E. Green. So katay duha ka theorem nga ginabasihan nganong yun sa niya pag-compute og deflection using area moment. The area moment method. Okay. First, we have the F-mat. What is F-mat? That is the first moment of area. First moment of area theorem. Okay. So, isa mo na siya. Say for example na kay point A and point B sa isa ka structure, then i-draw ni mo yung elastic curve between sa ilaha is kana. So at point A and point B makadraw ka og tangent lines. Okay, so this angle in between the tangents A and B, that is theta BA. That is the change in slope. Kung balihon po na to, hindi magyapon, no? Ang imuhang deflection is concave upward. So makadraw gyapon ka og tangents. So that is theta BA. Okay. So according sa first moment of area theory, the change in slope between the tangents to the elastic curve between A and B is equal to the area under the M/EI diagram between the 2 points, provided that the elastic curve is continuous between the 2 points. So, ano to? Ang change in slope ko, no? The change in slope between the tangents of the elastic curve. So this is the elastic curve. These are the tangents and this is the slope, or the change in slope between the tangents of the elastic curve between 2 points A and B is equal to the area of the moment, or M/EI. Okay, nasabutan ninyo. So the theta BA is equal to area M/EI from A to B. Okay, so wala siya ang first area of moment, first moment of area, first theorem. Okay, so proceed ta sa number 2. Ato lang i-elaborate po niya, ha. You have the S-mat. The second moment of area theorem. Okay. So let us say nagyapon kay 2 points A and B na mo niyang elastic curve, or ang curve sa deflection, no? mag-draw ka og tangents at these points okay. So diri gi-state nung second moment area theorem, the tangential deviation of B with respect to the tangent at A in a direction perpendicular to the original position of the beam is equal to the area of the M/EI diagram between A and B multiplied by the distance from B to the centroid of the area of M/EI. Okay. So medyo kuan siya, no? Medyo libog siya. Pero kung i-illustrate na to, mas maklaro siya, di ba? Okay. So, kung nakay tangents, duha ka tangents, no? Ang deviation sa duha ka tangents, so let us say this is deviation. Ang distance between sa straight line nga downward gikan sa tangent point B o taman sa line drawn from A. Okay? Tangent at B, line drawn from A. So that is tangential deviation B with respect to the tangent drawn from A. So that is deviation or tangential deviation at B. So ni-deviate ka at B with respect to the tangent drawn from A. Okay, so mo na siya pagkabasa ni TBA. Deviation at B with respect tangent drawn at A. Kanina po kay deviation dire. That is TA over B. So, timan na lang ninyo kung asa gikan ang point, kung asa ka mukuha og deviation, mo na ang nasa upper side tapad sa T. The lower portion is kung asa gikan ang tangent. The point and the tangent. The point, the tangent. From point B with respect to tangent drawn from A. From point A with respect to the tangent drawn from B. Okay, so that is the deviation at A with respect to the tangent drawn at B.